Hello everybody. Today we're going to be talking about calculating standard deviation. Make sure that you're writing down the notes in your notebook and that you're following along with any questions that we go over. Okay, so we're going to get started with a warm-up here. Based on what we've done in our previous lesson, complete these two parts below, A and B, and when you're ready to go over the answer, go ahead and hit play. Okay, so in part A, we're going to calculate the mean of these values, how many hours each student studies. So mean is the sum of all the values, which in this case, if we add them all up correctly, we should get a grand total of 112. Adding up each individual number here, 15 plus 8 plus 10, and so on. And then we're dividing by however many values we have. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8 values. Okay, so that's the setup. If we divide correctly, we will get a mean. Remember the symbol for mean, the X with a little bar on top, of 14. Okay, once we know what the mean is, we can take that and help us figure out this chart below, what we did in our previous lesson for calculating deviations from the mean. Now that we know it's 14, I'm just going to write all the values that we have. We can figure out how far each one deviates from the mean. Basically how far away it is, how much it varies. Okay, so 15, for example, should be plus 1, and so on. This is going to be very important for today's lesson. We're going to be basically applying what we did in the previous lesson, and we're going to use it, and even we're going to use tables like the one right here to help us figure out or calculate standard deviation. Okay, so what exactly is standard deviation? Standard deviation, the best way to think about it, if we think about what we did in yesterday's lesson or our previous lesson, where we talked about deviations from the mean. That's looking at each individual value and how much it varies, one at a time, right? Standard deviation is kind of taking the big picture. So in general, how do the values typically deviate from the mean? So it's taking everything into consideration. The formal definition is down here. Feel free to copy this down into your notes. It's a measure of how the values in a data set vary from the mean. So like I said, it's taking everything into consideration. All the values typically deviate this much or that much. The more the values are spread out, the larger our standard deviation is going to become. The values are all over the place, a lot of them not very close to the mean whatsoever. It's going to be a very high standard deviation. Kind of similar idea, the closer they are together, the closer they are to the mean, the more centered or symmetrical they are, the smaller the standard deviation is going to become. Okay? And like I said, think about it related to yesterday's lesson where we were looking at it individually. Standard deviation, very similar, but kind of just taking it big picture, incorporating everything and how much it typically deviates. If we look back at the warm-up, for example, the standard deviation is 5.86 hours. Notice that the unit is the same here. We were talking about how many hours people were studying, so it's still hours. And a typical deviation, taking into consideration all of our points, all of our data points, is 5.86. What I want you to do, after you watch this lesson, go back to the warm-up, try to calculate it using the steps that we're about to go over in a few seconds, and see if you get the same answer, 5.86. Okay, let's take a look at an example now at how we actually calculate standard deviation. With standard deviation, it's a very step-by-step process. So we're going to get started with step 1. We're looking at Odell and how many minutes he spends working out each day. Okay. The first thing that we're going to do, like we usually do with most statistical questions, we're going to figure out the mean. So to calculate the mean, we're adding all the values up. If we add them all up correctly, we should get 210. And as always, we divide by however many values we have. In this case, we're dealing with 7 values. So we get a mean of 30. Okay, so that's step 1. Whenever we figure out standard deviation, just remember too to write these blue notes down, the steps as we go along. The first step is to figure out the mean. Then, just like we did in the warm-up and just like we did in the previous lesson, we're going to be filling out a table with a little extra step involved. Okay, we're going to fill out the deviations from the mean. So now that we know the mean is 30, just like we did in the warm-up, we're going to be filling out the deviations. So we have a 0, a negative 8, plus 15, plus 5, minus 1, minus 6, and minus 5. And now, an extra step involved here, we're going to figure out the square deviations. So basically, I'm taking that blue row that I just wrote in and squaring each value. So I get 0, 64, 225, that's 15 squared, 25, 1, 36, and 25. Okay, so the same thing as the warm-up, just taking it one step further, squaring each value. That's step 2. Okay, next, if we keep going here, step 3, we're going to add up all these values. So just that green column, we're ignoring the blue one for now. We're just dealing with the green column that we just completed. Using a calculator really helps with standard deviation. We'll see in a second. We really need one. But for now, we can just add these up. Like I said, plug them in your calculator, and we should get a total of, if I add up all the green numbers correctly, 376. Okay, not my final answer yet. That's just step 3, so we added up everything. We got 376. Next, we're going to take that answer that we had. You can see what I mean with the steps here. We kind of keep going. And we're going to divide by n minus 1. So basically how many values we have, but one less than that. So we said earlier, we have 7 values, so n equals 7. But we want to divide by n minus 1. And minus 1 would be 6. So we're going to take that answer that we had, 376, from step 3, which was the sum of all of these values here, right? We're going to take that and we're going to divide it by n minus 1, which again is 6. The number of values, one less than that. Okay, 376 divided by 6 works out to 62 2/3, or 62.6 repeating. Okay, one thing I want to mention quick, this happens a lot in math. People round too early. For example, you wouldn't want to just call this 62.6. Leaving out key values early on in the problem, it doesn't seem like a big deal, but it can affect your answer a lot when you reach the end. So make sure you don't round too early. And last but not least, once we have that answer from step 4, after we divide by n minus 1, we take the square root. If we take the square root of 62 2/3, or 62.6666 repeating, we get a standard deviation, if we round to the nearest hundredth, of 7.92. And again, the same unit applies. So 7.92, we were talking about how many minutes he spends working out. So the standard deviation is 7.92 minutes. Again, that's a typical deviation considering all the values. So a typical variation, taking everything into consideration, is 7.92 minutes. Okay, so after you watch the video, make sure that you copy down all the steps into your notes. It's going to be very important, especially when we get into the lesson tomorrow, that we have the steps down. It's the same thing over and over again, just with different numbers involved. Also, really think about standard deviation, what it really represents, and how it relates to the distribution. What does it mean if a standard deviation is smaller? What does it mean if it's larger? Think about these type of things, and we will discuss them tomorrow in class. Okay, if you have any questions, feel free to submit them in the Google Doc, and thank you for watching.